This is SpaceTime Series 25, Episode 79. Coming up on SpaceTime, the James Webb Space Telescope reveals its spectacular first images. Russia officially kicked off the Exomars mission. And a blast rocks SpaceX's starbase in Texas. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The first images of the new James Webb Space Telescope have stunned the world with their spectacular beauty and clarity. The 5 first-light images have revealed starscapes showing the deepest and sharpest images of the distant universe ever undertaken. The amazing photographs include towering cosmic cliffs in a cloudscape of mountains and valleys speckled with glittering stars, and enormous nebulae where new worlds are being born and old ones have died. The telescope, which has taken over 27 years to design and build, was launched on Christmas Day last year, folded origami style inside the payload fairing of an Ariane 5 ECA heavy lift rocket, which was launched from the European Space Agency's Kourou spaceport in French Guiana. The $10 billion infrared observatory was flown to a gravitational well known as the Lagrangian L2 position, some 1.6 million kilometers away on the nighttime side of the Earth. From this high perch in permanent darkness, it'll observe the universe as never before. And along the month-long journey to its halo orbit, NASA began the painstakingly complex and delicate task of unpacking and unfurling the giant 20-meter-long spacecraft from the tight confines of its launch configuration. This was followed by 6 months of commissioning and testing, during which time the telescope was slowly cooling down to its final operating temperature. Its many mirrors, scientific instruments and cameras were activated, tested and aligned. While the groundbreaking Hubble Space Telescope is capable of seeing back through space-time more than 13.4 billion years, James Webb's 6.5-meter main mirror, comprising 18 hexagonal gold-plated beryllium segments, can look back much further and deeper, seeing back quite literally to the birth of the first stars and galaxies, just a few 100 million years after the Big Bang, 13.82 billion years ago. And unlike Hubble, which sees the universe in normal visible light, only just dipping into the infrared at one end and the ultraviolet at the other, James Webb looks through infrared eyes. That's because the light from the ancient times it's looking at has been physically stretched out of the ultraviolet and visible wavelength segments of the electromagnetic spectrum by the expansion of the very fabric of space-time since the Big Bang. NASA Administrator Bill Nelson says James Webb will help to uncover the answers to questions astronomers don't yet even know to ask.
You held a grain of sand on the tip of your finger at arm's length. That is the part of the universe that you're seeing, just one little speck of the universe. And what you're seeing there are galaxies that are shining around other galaxies whose light has been bent, and you're seeing just a small little portion of the universe. 100 years ago, we thought there was only one galaxy. Now, the number is unlimited. And in our galaxy, we have billions of stars or suns, and there are billions of galaxies with billions of stars and suns. And we're getting our first glimpse. As you said, Mr. President, we're looking back more than 13 billion years. Light travels at 186,000 miles per second, and that light that you are seeing on one of those little specks has been traveling for over 13 billion years. And by the way, we're going back further because this is just the first image. They're going back about 13.5 billion years. And since we know the universe is 13.8 billion years old, we're going back almost to the beginning. That is the discovery that we are making with this. There's another thing that you're going to find with this telescope. It is going to be so precise, you're going to see whether or not planets, because of the chemical composition that we can determine with this telescope of their atmosphere, if those planets are habitable. And when you look at something as big as this is, we are going to be able to answer questions that we don't even know what the questions are yet. This is what's happening. And it's because of this wonderful team that's out here. Part of that team, led by Thomas Zurbuchen, it was in trouble financially 5 years ago. He took it over. He got Greg Robinson to direct it. So what an incredible team, joined, by the way, with our international partners, the European Space Agency and the Canadian Space Agency. So this is an international endeavor.
That's NASA Administrator Bill Nelson. The first image released to the public was a deep-field image of a far-off galaxy cluster known as SMAC 0723. The image, taken by the telescope's mid-infrared instrument, uses a lensing foreground galaxy cluster to find some of the most distant galaxies ever detected. Captured over an exposure time of just 12.5 hours, this new image is a color composite of multiple exposures, each about 2 hours long, looking at a tiny, seemingly empty patch of sky, revealing countless galaxies, showing the universe to be even bigger than anyone could ever imagine. Yet this image only scratches the surface of Webb's capabilities in studying deep fields and tracing galaxies all the way back to the beginning of cosmic time.
On Monday, July 11th, NASA Administrator Bill Nelson released the first scientific quality image taken by the $10 billion James Webb Space Telescope at the White House. According to NASA, the image is the deepest infrared vision of the cosmos to date, and it was obtained using only 12.5 hours of observation time on one of the telescope's 4 sensors. Today, we can officially announce that NASA's James Webb Space Telescope has produced the deepest and sharpest infrared image of the distant universe to date. Known as Webb's first deep field, this image of the galaxy cluster SMAC 0723 is overflowing with detail. This deep field, taken by Webb's near-infrared camera, NIRCam, is a composite made from the images at different wavelengths, totaling 12.5 hours, achieving depths at infrared wavelengths beyond the Hubble Space Telescope's deepest fields, which took weeks. The image shows the galaxy cluster SMAC 0723 as it appeared 4.6 billion years ago. The combined mass of this galaxy cluster acts as a gravitational lens, magnifying much more distant galaxies behind it. Webb's NIRCam has brought those distant galaxies into sharp focus. They have tiny, faint structures that have never been seen before, including star clusters and diffuse features. Researchers will soon begin to learn more about the galaxy's masses, ages, histories, and compositions as Webb seeks the earliest galaxies in the universe. SMAC 0723 is a particularly good target for this sort of observation because there are massive clusters of galaxies in the foreground. These act like giant cosmic magnifying glasses. Because of their immense mass, their gravity causes a pronounced curvature of the space-time around them, with the effect of magnifying light from more distant objects. NASA has already announced some of the celestial objects that space enthusiasts might expect to see in these photos. Views of the Carina and Southern Ring nebulas, as well as Stephan's quintet of densely packed galaxies. WASP 96b observations are also on the program, albeit JWST will not provide a picture of the distant world. Instead, scientists will present a spectrum of the planet, which divides light into wavelengths and provides information on the planet's chemical composition.
Their report from NASA TV. Other images in this first release by the James Webb team include the enormous cosmic cliffs of the Carina Nebula at the edge of a young star-forming region called NGC 3324. The image unveils the earliest rapid phases of star formation which were previously hidden. By looking at this young star-forming region in the southern constellation Carina, as well as others like it, Webb can see newly forming stars and study the molecular gas and dust that they're made from. And while Carina showed us a stellar nursery where new stars are being born, another image showed what's known as the Southern Ring, a stunning planetary nebula, an expanding cloud of gas and debris surrounding a dying star called a white dwarf, located some 2,000 light-years away. Here, Webb's powerful infrared eyes have shown the heart of the nebula contains not one but two dying stars, entwined in a cosmic dance of death. From birth through to death as a planetary nebula, Webb can explore the expelling shells of gas and dust of aging stars that may one day feed into material that eventually becomes part of a new generation of stars and planets. Also on display was Stephan's Quintet, a compact group of galaxies located in the constellation Pegasus. James Webb pierced through the shroud of dust surrounding the center of one of the galaxies to reveal the velocity and composition of the gas near its supermassive black hole. Now, scientists can get a rare look in unprecedented detail at how interacting galaxies are triggering star formation in each other and how the gas in these galaxies is being disturbed. But as well as peering back to see the most distant stars and galaxies, James Webb will also allow scientists to examine the atmospheres of planets orbiting other stars, and in the process, search for any telltale signs of life, and maybe finally answering the question as to whether or not we're alone in the universe, both options of which would be equally frightening. Included in James Webb's first offerings is the spectra of an exoplanet known as WASP 96b, revealing clear signatures of water in its atmosphere, along with evidence of haze and clouds that previous studies could not detect. With James Webb's first detection of water in the atmosphere of an exoplanet, it'll now set out to study the chemical composition of hundreds of other worlds in order to better understand what planetary atmospheres are made of, to find out just how unique our Earth is. Professor Fred Watson, an astronomer with the Department of Science, says James Webb has opened up a window on an entirely new era of astronomy, allowing science to better understand the universe and humanity's place in it.
We sort of expected to be blown away, Stuart, because this has been a long time coming. I mean, the project's been going for 30 years. And after the successful launch in Christmas Day last year, and that month getting to the L2 point where it's stationed, and then tuning up all the instruments, it seemed interminable to get to the nitty-gritty of what we might be seeing. But I don't think anybody among my colleagues, and certainly I wasn't disappointed. I don't think any of them were disappointed. I think we've seen a really spectacular choice of images to give us an idea of what this telescope is going to be able to do. And this is day one. This is remarkable that we've got such high quality, such deep, such detailed images with really just the commissioning team having got everything tuned up and said, here you go, chaps and gals, get on with it, because it's now your telescope. And usually it takes people a while to learn how to get the best out of an instrument like this. But what we've seen today, I think, means that they're doing pretty well.
I've done a few radio interviews on this matter already, and the one that keeps getting me is the spectroscopic data on the exoplanet, the atmosphere of the exoplanet. And you're laughing because you obviously think the same. That's
exactly the same. Yeah, if I was going to highlight one of those, that would be it. And that's because I've been a spectroscopist all my working life. And, what career I've had has been built on spectroscopy of stars and galaxies. So, yeah, it was a great spectrum to see. And an unequivocal detection of water vapor in the atmosphere of WASP 96b. What's really great is that this is in a wave band that we're challenged to observe from the ground. It's mid-infrared. You find that region of the spectrum is absolutely riddled with atmospheric lines, emission lines, this barcode of structure, which come from the Earth's atmosphere. It's from things like the OH radical and things like that in the Earth's atmosphere. And they make it a nightmare trying to tease out the signals that might come from a star or a planet such as WASP 96b. And of course, the James Webb is above all that. We don't have to worry about that until you've got this really good start when it comes to trying to extract the spectrum of a planet's atmosphere as it goes past its parent star and transits across its disk. So yes, I too was blown away by that.
Is this the pinnacle of infrared astronomy?
For the moment, it is, because this is the best thing we have for looking at the infrared radiation that we see from the universe. And as we were just saying, it's unfettered by the effects of the Earth's atmosphere. We've got a absolutely very useful sized telescope up there at this L2 point in space. That 6.5 meter diameter mirror is absolutely top notch in terms of today's telescopes, which are classic telescopes today are 6.5 to 10 meters in diameter. They're the biggest ones that we have. But putting it above the Earth's atmosphere, getting rid of all that interference, giving you absolutely crystal clear, sharp images without the turbulence of the Earth's atmosphere thrown in to make it even worse. That makes it definitely the pinnacle of infrared astronomy. Pinnacles in astronomy are something that tend not to last forever. They last a long time, and in fact, astronomical telescopes generally last a long time, and even space telescopes do. The Hubble's still going strong after 32 years. So I would envisage that in maybe 2-3 decades, we might be looking at something even bigger, Stuart, that's going out there to look at the infrared universe in even more detail. And of course, by then, we will also have ground-based telescopes, which are much, much bigger than the James Webb. The European Extremely Large Telescope, when that comes on stream, will have a mirror 39.3 meters in diameter. Of course, it's still sitting at the bottom of a turbulent atmosphere. It's got technology to remove the turbulence of the atmosphere, but it doesn't have the access to the full infrared spectrum that the James Webb does. So it's not going to be a serious competitor in certain wave bands. But we're in for a very exciting time. That will come on stream by the end of the decade, we hope. So hopefully the Webb and the ELT will together provide some extraordinary new knowledge about the universe at large.
Got the square kilometre array on the way too.
Exactly. And thank you for mentioning that, because that was where I was going next. That's right. And certainly by the end of the decade, the two halves of the square kilometre array, the mid-frequency half in South Africa and the low-frequency half here in Australia, that will be in full swing. Construction's already started on both. Contracts have been let. There's still some high-level deliberations that are going on regarding the use of the land and things of that sort. But generally speaking, it's in very good shape. And we expect that the radio universe will also get this sort of foot down on the accelerator that we've seen now for infrared astronomy with the James Webb Telescope.
Well, just the data we've been getting from Murchison and ASCAP have been absolutely amazing. We're seeing things in resolution and detail we've never seen before.
That's right. And that's just a taster. So the Murchison Wide Field Array, which is located where the SKA will be, and actually operates at in a very similar frequency range, that is doing extraordinary work. And when you see it, it's totally underwhelming. Stuart, I don't know whether you've ever been out there
bunch of Christmas
and had well, that's what the SKA will be. The Murchison Wide Field Array looks like a bunch of coat hangers that somebody's left lying around, but there are the dipole antennas like the Christmas trees. The Christmas trees are a step up from that. And yes, the ASCAP itself, the Australian Square Kilometre Array Pathfinder, that has done extraordinary work, particularly with regard to quite new phenomena like the fast radio bursts that have been followed up in a big way using ASCAP. So we're spoiled for tools in terms of astronomy. And my guess is that by the end of the decade, we'll have a very different picture of the universe from what we have now because of all these facilities combined and what they will tell us not only about the universe around us today, and that includes things like the planet WASP-96b and the nebulae in our own galaxy that we saw the images of today. It includes not just that, but looking back to the earliest period of the universe when we will see what the universe was like before the first stars and galaxies started shining.
That's Dr. Fred Watson, an astronomer with the Department of Science. And this is SpaceTime. Still to come. Russia officially kicked off the EXOMARS mission to the Red Planet and a successful maiden flight for Europe's new Vega C rocket. All that and more still to come on SpaceTime. Okay, let's take a break from our show now for a word from our sponsor, Nordvpn. You know, these days people need to take extra care about what's happening online. They need to be concerned about their online privacy and security. And that is where Nordvpn comes in. It helps to protect you and your family from online threats, keeping your identity and data safe and secure. Now, everybody knows Nordvpn is simply the best virtual private network anywhere in the world. Right now, you can subscribe to the Nordvpn Complete Security Package for 69% off the normal recommended retail price. Now, with this package, you get 2 years of Nordvpn protection, plus malware protection, plus tracker and ad blocker, plus the cross-platform password manager NordPass, plus a data breach scanner, and 1 terabyte of encrypted cloud storage. It's an amazing package, and it will help make your family safe and secure online. And of course, you can load all of this onto all of your devices. And don't forget, it comes with a 30-day money-back guarantee, so you've got nothing to lose. And no reason you shouldn't at least give it a try. Now, it's the most complete security package available. And if you don't want to go that far with your security, well, we have 2 other great NordVPN packages available, and they all represent incredible value for money. You can find out full details on all 3 packages by visiting nordvpn.com/StuartGary and then click on the Get the Deal button. The promo code for the special deal is StuartGary. That URL again to get NordVPN's complete security package is nordvpn.com/StuartGary and will include the URL details in the show notes, and of course you can find them on our website. And now it's back to our show.
This is SpaceTime with Stuart Gary.
The European Space Agency has now formally terminated cooperation with the Russian Federal Space Agency Roscosmos on the joint EXO-Mars mission to put a rover on the surface of the red planet to drill for signs of life. ESA had previously suspended ties with Russia on the mission in response to Moscow's invasion of Ukraine. ESA's also already cancelled all commercial payload launches using Russian rockets and suspended the launch of Russian Soyuz rockets for Ariane space flights from ESA's Kourou spaceport in French Guiana. The EXO-Mars mission was to use a Russian Proton rocket to launch from the Baikonur Cosmodrome and the Russian Kozachuk landing platform to deliver Europe's Rosalind Franklin rover down to the Martian surface. Kozachuk would then carry out some stationary scientific investigations at the landing site once the rover was deployed. ESA's Director General Josef Aschbacher says because of Russia's war against Ukraine and the resulting sanctions by the European Union, his agency was officially terminating ties with Russia on EXO-Mars and its landing platform. Firebrand Roscosmos chief Dmitry Rogozin quickly issued an angry response, saying he had now ordered his crew aboard the International Space Station to stop working with the new European robotic manipulator arm. The arm, which looks like a pair of compasses, is one of 3 robotic arms that crawl around the outside of the space station. They're used to transport equipment, replace components, service other items, and help move crew around on spacewalks. The thing is, the new European arm was only installed a couple of months ago, and it's the only one designed specifically to reach the Russian segment of the space station. Without it, it's going to mean a lot more work for the Russians. The EXO-Mars launch had already been suspended once back in 2020. That was initially due to equipment issues. Then the COVID-19 pandemic struck. Things were on schedule for a launch this year, in just a couple of weeks in fact. But that was until Russia started bombing Ukraine. As for the EXO-Mars mission, well, Aschbacher is now in talks with NASA to use some of their technology instead of the Russians to launch in 2028. Of course, this delay means EXO-Mars is unlikely to reach the red planet much earlier than the Mars Sample Return mission, which ESA and NASA are already working together on. Still, scientists would like the EXO-Mars mission to proceed because its rover uses a massive 2-meter drill that can go far deeper than the drills on either the Curiosity or Perseverance rovers. And that means EXO-Mars will collect samples from much deeper down, from places where any samples of past or present life on Mars are far more likely to survive. Ironically, NASA was ESA's original partner for the EXO-Mars program, but the American Space Agency was forced to withdraw in 2012 following budget cuts by the Obama administration. This is SpaceTime. Still to come, a successful maiden flight for Europe's new Vega C rocket, and later in the science report, a new study warns of increased heart disease and diabetes risk after getting COVID-19. All that and more still to come on SpaceTime. Europe's new Vega C launch vehicle has undertaken a successful maiden flight, delivering a scientific satellite and 6 Cubesats into orbit. Ariane Space Flight VV21 was launched from the European Space Agency's Kourou spaceport in French Guiana.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P120 et décollage.
Of the very first Vega C on her inaugural flight, clearing the mast, like you said, in a blink of an eye.
Trajectoire nominale.
Just see it through the cloud. Oh, it's a technology high on the leading edge of life there.
Pilotage calme.
Be quick, Dante, and you are not joking. It's like George Russell in a racing car.
Trajectoire nominale.
From the beach in Kourou, yes, look at how fast it is. The acceleration is more than 2G.
Acquisition, télémesure par station Saint-Jean.
200 Formula One cars pushing together. And we have
Les paramètres à bord sont normaux.
The flight director saying that all the parameters are nominal and everything is going well so far.
Yeah, it's already going faster than a fighter jet. It's just past that milestone.
Pilotage calme.
We're following the rocket, of course, because it's visually it's out of sight.
Trajectoire nominale.
There we go. Everything's normal. Flying under the propulsion of the P120C developed by Euro Propulsion, a joint venture between Ariane Group and Avio. We're already coming up to a major double milestone in a few seconds.
P120.
And
Pilotage calme.
Dante will explain what that double milestone is. It's a unique, complex separation of the spent
Trajectoire nominale.
Yes, we are hearing that the trajectory is nominal, parameters are nominal, P120C is slowing its thrust, and we are approaching the separation. Let's wait for the announcement of the flight director.
Séparation P120.
There he goes. He's
Allumage Z40.
and it's ignited.
Yeah, this is already a very major milestone of this flight because we had the in-flight qualification, so demonstration that we fulfill all the objectives and requirements for this first stage that can be considered qualified for future Vega C missions and flight proven to be used as strap-on booster for the upcoming Ariane 6. We have these 8 small retro rockets that they provide a retrograde thrust to the P120C because it is so big and with so much residual inertia that we must be sure it won't hit the rest of the rocket once separated.
So, of course, we heard the DDO announce, the flight director announced that the Z40 ignition, the second stage, which has a 92-second burn time, and we're doing this dogleg maneuver as well now. So this is the second stage. It's also like the first stage. It's a solid rocket motor. Talk me through the Z40, Dante.
Solid rocket motors that in less than 2 minutes will bring the rocket up to 16,000 kilometers per hour speed and more than 180 kilometers of altitude.
Trajectoire nominale.
Yeah, that's
Tous les paramètres à bord sont normaux.
And parameters are nominal, and then we are approaching also the separation of the second stage that as well is doing its first in-flight mission. So in a few seconds we should listen to the flight director.
We're going to have the second stage separation, and we'll wait for the DDO to announce that. But we're also going to have ignition of the third stage and fairing release in quick succession.
Séparation Z40.
And there it is. Separated. Frederic?
Allumage Z9.
Yes, and it is firing. And there was my favourite moment.
Séparation de la coiffe.
And DDO confirms it actually happens. It's the separating of the fairings. You're exposing your payload to the rushing wind as the rocket barrels through space. But of course, we're well into space now. We're twice the height of the Kármán line. So Dante, tell me what's happening here.
Look, we are already at 194 kilometers of altitude. It means the atmosphere there is so thin that there is no possible harm to the payload. So for this reason, we get rid of the fairing because its aerodynamic and protection functions have expired, and now it has just
Trajectoire nominale, paramètres à bord nominaux.
So now we don't want to bring up with us to the very end this useless mass, because the lighter you are, the more performance you get and the better it is.
The third stage, and it's flying.
Paramètres à bord normaux.
And everything is still normal. That third stage is almost spent now. It's how's it different? It's no different from the other 2 stages, is it?
No, it's just smaller, but it brings the most difference in terms of gain in speed.
Séparation Z9.
There we go. The Z9 has separated. Confirmation. It will safely fall near the pole. That separation of the stage falling down.
This is amazing. Yeah.
Awesome.
The mission's primary payload was the 296-kilogram LARS-2 spacecraft, which will be carefully tracked by a laser from ground stations to measure a phenomenon known as frame dragging, an effect first predicted by Albert Einstein in his general theory of relativity. Frame dragging is a distortion in local space-time caused by the rotation of a massive body, such as the Earth. Now, while it's not noticeable to the human eye on the scale of the Earth, on the scale of something much more massive, such as a black hole, it becomes a dominating feature. A similar payload, LARS-1, was carried aboard the maiden flight of the original Vega rocket back in 2012. 6 Cubesats were also included in this latest mission as a secondary payload package. These include 3 Italian Cubesats, AstroBio, which will test a solution for detecting biomolecules in space, Green Cube, which carries an experiment to grow plants in microgravity, and Alpha, which aims to understand phenomena related to the Earth's magnetosphere, such as the northern and southern lights, the aurora borealis and aurora australis. Also on board were 3 other Cubesats, which will study the effect of a harsh radiation environment on electronic systems. These were Slovenia's Trisat R and the French MT Cube 2 and Celesta. The Vega C is a very different rocket to its predecessor, the Vega. The new Vega C core stage consists of a P-120C solid rocket booster, which is a far more powerful rocket based on the original Vega P-80 core stage. In fact, the same P-120C booster will be used in pairs as strap-on boosters on the new Ariane 6 heavy lift vehicle, which will replace the current Ariane 5 either later this year or early next. The Vega C features a new Zefiro 42nd stage, as well as the same Zefiro 9 third stage used on the original Vega. The Avum Plus upper stage has also been upgraded to allow longer burn times, thereby able to undertake more maneuvers or move a payload greater distance. With its new first and second stages and the uprated fourth stage, the 35-metre tall Vega C can now carry 2.3 tons into a 700-kilometre high polar orbit. That compares to the original Vega's 1.5-ton payload limit. A SpaceX Starship Super Heavy booster has suffered a spectacular launch pad explosion at SpaceX's Starbase facility in Boca Chica, Texas. The blast doesn't appear to have been a full detonation, as the blast wave wasn't moving fast enough. Rather, it looks like methane propellant overflowing from a spin prime test may have settled under the rocket engine nozzles and then suddenly ignited in a spectacular-looking fireball. Spin prime tests spin up the turbines of the rockets in order to show that the launch vehicle's plumbing's all in correct working order. Now, there's a bit of propellant which flows through the system during these tests, which would then vent out through the nozzles. Now, normally this would quickly evaporate with the wind dispersing it and blowing it away. But it looks like on this occasion there may not have been enough wind, and so the methane simply pooled there until a spark ignited it. As for damage, well, the launch pad and structure are designed to easily handle the sorts of pressures that would have occurred during this blast, so they weren't damaged. Maybe some of the ground service equipment may have ended up a bit bent and equipment lockers crushed, but that's about it. As for the booster itself, if it was pressurized, which it should have been, it should be okay. And that's now pretty well been confirmed by SpaceX boss Elon Musk, who's tweeted that the base of the booster seemed okay. He says damage to the booster propellant section appears to be minor, but there will need to be an inspection of all 33 Raptor 2 engines fitted to the booster, and that'll mean a rollback to SpaceX's version of a vehicle assembly building, which they call the High Bay. SpaceX were testing their Super Heavy Booster 7 at the complex in preparation for Starship's maiden orbital flight, which was slated for this month. Starship and its Super Heavy booster were being prepared for eventual pressure testing and a static fire test. With Starship stacked on top of the Super Heavy booster, the massive rocket stands more than 120 meters tall. That's bigger than NASA's SLS Artemis moon rocket. The new spacecraft's been developed by SpaceX as the reusable interplanetary colonial transport system, carrying people and equipment on missions to the Moon, Mars and beyond. NASA's already picked Starship to be the first crew lunar lander for its Artemis program, which it hopes will return humans to the moon in 2025. Speaking of SpaceX, the Hawthorne, California-based company has now set a new record, flying the same Falcon 9 booster for the 13th time. The historic launch of Pad 39A at the Kennedy Space Center in Florida sent another 53 Starlink broadband internet satellites into orbit. And 8.5 minutes after launch, Falcon 9 core stage returned to Earth, successfully landing on the drone ship a short full of Gravitas, which had been pre-positioned downrange in the North Atlantic Ocean. SpaceX will now refurbish the core stage for a possible record 14th launch. But the Falcon 9 still has a long way to go to set a world record. That's currently held by NASA's Space Shuttle Discovery, which undertook some 39 orbital missions, more than any other shuttle, before the fleet was prematurely mothballed in 2011. Just 2 weeks after the Starlink 49 mission, SpaceX successfully delivered the SES-22 C-band telecommunications satellite into geostationary transfer orbit. The mission aboard a Falcon 9 rocket was launched from Pad 40 of the Cape Canaveral Space Force Base in Florida. That's virtually adjacent to Pad 39A. The Falcon 9 first stage then returned safely to Earth, landing on the drone ship a short full of Gravitas, while the payload fairing halves were retrieved for reuse by the support ship Doug. SES-22 will deliver radio, TV and data transmission services across the United States. SES are launching 5 of these new Thales-Alenia-built satellites this year. It's all part of new FCC requirements for satellite operators to migrate their services from the lower 300 MHz to the upper 200 MHz of the C-band spectrum in order to free up more room for 5G. And just a week after the SES-22 launch, SpaceX flew another Falcon 9 from the same launch pad, this one carrying another 53 Starlink satellites into orbit. And this mission marked the company's 50th Starlink launch, as well as providing a second Falcon 9 booster, which has now recorded 13 flights into space. And just as before, the booster returned safely to Earth, landing on the drone ship. Just read the instructions. SpaceX have now launched 2,805 of the 260-kilogram Ku, Ka and E-band telecommunications satellites, with current plans to launch another 27,000 in order to complete their constellation. This is SpaceTime. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.